Welcome. Today, we're going to talk about some interesting innovations and important innovations in MySQL HeatWave. Specifically, we're going to focus on automation capabilities, much more scalable, much larger data sizes, and also a lot more performance. Now, we originally released MySQL HeatWave in October, limited availability, and we announced MySQL HeatWave in December. When we built MySQL HeatWave, we had some clear customer requirements in mind. For one thing, customers want single databases for all their applications. They don't want to have to use a lot of different specialized databases. Customers tend to use specialized databases, but that's because they have to, not because it's their choice. Customers didn't want to have to do ETL. So when you have an OLTP system separate from an analytics system, not only do you have to pay for both of those databases, but you have to actually build a lot of ETL to move data from the transaction processing system into the analytics system. When you do that, not only do you have to do the work to build and maintain and manage that ETL flow, but it means that the data that's in your analytics engine, it's stale. Your queries aren't real time. When you run analytics queries, you're not looking at the latest data from your OLTP system. That makes a big difference. And of course, customers don't want to have to change their application. They want to use the same code that they wrote, against maybe an on-premise MySQL database instance when they move to some other database. Now, we built MySQL HeatWave to solve all those problems. It is a single solution supporting both transactions and analytics. And by the way, something else I think is very important, which is mixed workloads. Running queries as part of your transaction processing application, just integrated into the code. I mean, if you write code that's database code, you write code against MySQL, you often run complex queries just as part of a normal transaction flow. MySQL HeatWave is a single solution integrated together. Specialized OLTP processing nodes, specialized query nodes running together. So you get real-time analytics. You get real-time decision support queries integrated into your OLTP application. It scales to thousands of cores. It's more than 1,000 times faster than other MySQL services. And all of your MySQL applications running today, all of the clients you currently use, they run against MySQL HeatWave without any change. You can take an existing on-premise application, you can take an existing Aurora application, you can move it to OCI, you can move it to MySQL HeatWave without change. We designed MySQL HeatWave from the ground up for cloud. That means it's designed for scale-out processing. It's elastic, it can grow and it can shrink. It runs on OCI infrastructure. That means we get to take advantage of the performance and security that's naturally part of OCI. And it uses machine learning, and we're going to talk a lot about that more later. This results in a service that is much more performance. It's much faster. It's highly automated. It's very scalable, and it's low cost. Since we launched MySQL HeatWave, it's become a very popular service. In fact, it's one of the fastest growing services we have in OCI. Customers love it. But like I said, they've asked us some questions that we've answered with the innovations that I'll describe today. First of all, they want to know, how can you make it even easier to use? Being a cloud service, being serverless, we already took away a lot of the trouble and hassle of managing a database. I mean, you don't have to patch it. You don't have to do much in terms of provisioning other than click a button. But now we can do even more. They asked us to handle even larger data sets. I mean, you could handle large data sets before. Now you can handle huge data sets. They asked us, so HeatWave has got an analytics engine coupled to OLTP. Does that mean that I can run mixed workloads? The answer is definitely yes. And I'll show you today how we can do that. They asked, can you accelerate more queries with HeatWave? When we first launched HeatWave, there were some queries that we couldn't accelerate. I mean, they had certain features that we couldn't actually handle in the analytics engine. We've now removed many of those restrictions, and so we can run a much wider range of queries now in the analytics engine. They asked us, can you secure the data even more? And the answer is yes, and I'll show you how. The heart of our automation innovation is something we call MySQL Autopilot. So MySQL Autopilot is machine learning-based automation. Now, when you run a cloud service, it's actually a great target for applying machine learning to do automation. And the reason is that in the cloud, in our cloud, in our MySQL service, we get real-time metrics for lots of important low-level system things, like how much memory is being used, exactly how the processors are being used, exactly like what is the storage bandwidth, what's the network bandwidth look like, where are the bottlenecks, and we can take all of that information and we can use that. We can build statistics on it to feed it into a machine learning system. We, of course, totally control the configuration parameters, which means that the autopilot can actually adjust those parameters. Those parameters are totally under autopilot's control. We have total control of the underlying hardware. That means that our machine learning models, they only need to target a relatively small number of physical configurations, which makes it much more effective. And finally, of course, we completely control all of the software versions of all of everything. I mean, firmware, operating system, MySQL software we wrote, HeatWave software, absolutely everything is under our control. Now, why use machine learning? I mean, some people might say, well, you could just write rules, to do automation, for provisioning or whatever else. Well, the answer is that if you use machine learning, you can take all that data, you can feed it into machine learning models. The system itself becomes more intelligent over time. It will infer important connections that just a human being would never be able to do and would never be able to actually code correctly using rules. The machine learning in Autopilot for MySQL HeatWave, we build instance-specific models. So what that means is that we train those MySQL Autopilot models on your running instances. So what Autopilot chooses to do in your instance is tuned specifically for your instance. We don't do learning across the big sea of MySQL HeatWave instances and apply what we learn to everyone. For one thing, that might not be secure. That data stays totally within your instance. It does not somehow leak into other customers' instances. But more importantly, if you care about performance, is that what is good for your instance may be very different than what is good for a different customer's instance. It completely depends on the set of queries you're running and your data statistics. You need machine learning models that are for you, not for someone else, and that's what we do. It allows us to adapt to changes without having to reprogram rule. I mean, when you first begin building your application, maybe you've got a certain sort of data skew. You've got a certain sort of cardinality on some column. You've got a certain mix of queries. That changes over time, where so does the models that are built as part of MySQL Autopilot. We can predict improvement and we can provide explanation. That, by the way, is very important, because sometimes when a machine learning system makes decisions, people want to know why, because sometimes it seems counterintuitive. Well, we can explain why, and that helps you understand why Autopilot made the decisions it did. Building MySQL Autopilot required innovation from the ground up. Okay, for one thing, it's great that we get access to real-time metrics, but it's a lot of data, right? So we need to sample. And to sample well for machine learning application requires a lot of sophistication. So we've developed sophisticated adaptive sampling algorithms to extract data from all those real-time metrics and feed it into the ML pipeline. We need to extract statistics, from that data that we've adaptively sampled. And we do that using proprietary algorithms we developed over many years in Oracle Labs and as part of the MySQL HeatWave project. We have something called Oracle AutoML. Now, I'll talk more about that in a minute, but Oracle AutoML is a technology that lets us master the machine learning process. Machine learning is not an easy thing to do well. I mean, it's, for a lot of people, it's more of an art than a science. And we couldn't possibly make that work in something like MySQL HeatWave. Finally, we need to make the service lifecycle of MySQL HeatWave be data and workload driven. We need to use that machine learning insight to actually drive provisioning in other parts of MySQL HeatWave. If you have some experience doing machine learning, you probably know that machine learning in some ways is seems like an art and more than a science. And the reason is that there are lots of different sorts of machine learning algorithms. And for every one of those algorithms, there are lots of different hyperparameters, basically things that you can tune that can have a radical impact on the model's performance. Well, we didn't just pick, some particular individual algorithm for some particular aspect and some particular set of hyperparameters that are used across everyone, because that wouldn't work. First of all, it would be very hard for us to pick the best one, and it just wouldn't work if we tried to apply exactly the same set of hyperparameters to everyone. So instead, we use something called AutoML. So what AutoML does is it basically runs experiments on your data. It looks at your data and determines what is the best algorithm. What is the best set of hyperparameters to use? What are the best features of the data to use? And what you get at the end is a tuned model. So Oracle AutoML is generating for our MySQL HeatWave customers optimized models built specifically for them to automate their MySQL instance using their data and only their data. If you look at MySQL Autopilot, it's broken up into two basic kinds of behaviors it has. First, it advises. So for things like provisioning nodes, how many nodes did you provision? It gives you advice. It also advises on where to place data. So among those nodes, how should you actually arrange the data, right? It also advises on encoding. So, in MySQL HeatWave, you have more than one choice on how to represent a given kind of value. And MySQL Autopilot helps you choose. Now, this is all advice. You can override MySQL Autopilot. You don't have to take the advice. But generally speaking, you're best served if you do. It does a very good job. The other thing it does is it just fully automates certain operations. You never see it. So for one thing, it can notice if a node is misbehaving and needs to be reprovisioned. It can also tune query execution. So it observes and watches, your queries running to understand, how resources are being consumed. So it can execute that query faster, but also other queries that consume the same resources. And we'll talk more about that later. But first, I'd like to introduce TetrisCo.
Hi, my name is Pablo Lemos. I'm co-founder and CTO at TetrisCo, and we are a MarTech startup. We gather advertising data to provide business intelligence in Brazil. We are facing a few challenges. First, we realized that we needed to expand our analytics beyond the C-level, beyond only the key decision makers, to the people handling the campaigns every day, like agencies and analysts inside the companies. We need to have everyone on the same page, so we need to give access to everyone of our insights and predictions. So that means more data, more segmentation, more deeper analysis for people handling the campaigns. Also, we had an expansion plan. We realized that our software and services were so automated that we could start to go from bigger clients to medium and small clients. And that means increasing exponentially the volume of data that you need to process inside an environment with an ever-growing data source and segmentation demand, with blazing fast speed, also at reasonable costs. And we've been doing the old solution that we all know. Transfer your data to a whole different database, because we have a transactional database that you're using Amazon Aurora, and to have the power of analytics, we need to transfer the data and inside Amazon using events and eventually put our data in S3 buckets, and eventually our data would land in Redshift, and only at that moment we would be able to use analytical power. When I saw this problem that we need to solve, I was 18 months searching for a solution, and it was mind-blowing to see that there was no simple solution in the market for this problem. Every solution was you deal with the headache of transferring your data, you deal with high costs of having a whole different database, a whole different infrastructure to host your data. And then we found MySQL HeatWave, and that was like a dream come true. We managed to accelerate very complex queries from minutes to milliseconds. And we start to be able to do things that first were impossible to do with just Aurora, but also even if we consider Aurora plus Redshift or Aurora plus Google BigQuery, HeatWave is much faster. It just works. So we achieved what I'm calling real time. As soon as we write the data on MySQL, the data is available on HeatWave to provide insights to our clients. We have this expression in Portuguese, encaixa como uma luva, fit like a glove. It means that it works perfectly. MySQL HeatWave dramatically reduced our costs, more than 50% compared to AWS Aurora plus Redshift. And all this move, all this migration took less than a month. And I'm considering here all the testing, all the iteration, everything we needed to do to use this brand new technology. And all of this feels that's just the beginning. We're testing now MySQL HeatWave Autopilot. It's a feature that applies machine learning to optimize workloads. It's built inside HeatWave to make queries faster and easier to use. And of course, the fact that it is inside the Oracle Cloud provides much more opportunities to automation. And we're already thinking how we can improve our software with this whole new infrastructure. We are seeing already direct positive impact in our business. Our clients have no more fear to ask the data. At any point, at any meeting, they can ask what happened in the past, what's happening now, and what will happen in the future with our machine learned algorithms, and have answers in seconds or milliseconds. And so we have faster and more precise analytics using real time during meetings, a better understanding of ad performance, more strategical thinking. And moreover, it made it possible to implement our expansion plan. It gave us scalability. Now with HeatWave, we can onboard many more clients and much more data without impacting our costs. All that thanks to the HeatWave. Thank you. Obrigado.
Okay, so I mentioned that MySQL Autopilot helps you provision. It gives you advice on provisioning. Now, if you've used any sort of cluster product before, I mean, especially if you've used any kind of cluster database before, I mean, it doesn't have to be MySQL, it doesn't have to be HeatWave, it doesn't have to be Oracle, could be Redshift, could be lots of cluster databases. And you know that one of the hardest things to get right that you have to do by hand is choosing a cluster size. How much cluster resources should I consume for my application? And so what HeatWave does with MySQL Autopilot is advise you on exactly how many nodes is best for your application. And it does this not only looking at your data, your schema, the volume of data, also looking at the queries, because the queries that you run dramatically affect which number of nodes is the best choice for your application. So we've tested this against some benchmarks, and we've tested this using real live customers currently using MySQL HeatWave, right? And you can see if we predict the amount of memory that you should consume, not just to hold your data, but to execute your queries most efficiently, right? And it turns out that the amount of memory that we can predict for your application and your queries is very accurate. So in the case of TCPH, you see it's like 98%, 97%. In case of those customer workloads, very similar, 98%, 97%. Because we can correctly predict how much memory you need, not only for your data and memory, but also all the intermediate results of all of the queries you're executing, we can tell you with very high accuracy what is the best number of nodes to have in MySQL HeatWave. Now, another choice you have to make when you're running in parallel databases, databases where the data is spread across multiple nodes for processing is, okay, how am I going to partition the data? How am I going to arrange that data? Again, very important for performance. I mean, if you get this wrong, what would otherwise be a high performance database will be very slow. Okay, so MySQL Autopilot advises you on how to place your data. Again, not just looking at your data, but also looking at your queries. I mean, I think most DBAs, what they do, first guess, is they try to just partition based on keys. It's usually a decent guess. It's not usually the best guess, though, right? And you can see that when we run benchmarks. So here we have TCPH. We're comparing TCPH, partitioning based on keys, versus partitioning based on the advice from MySQL Autopilot. And you see a dramatic improvement, 37% and 25%. Dramatic improvements in performance achieved by just running MySQL Autopilot to get advice. Now, that's not only are you going to get better runtime, but think about all the time that you or your DBA spend trying to tune and optimize data placement. Instead, you could just let MySQL Autopilot do it for you. Now, I mentioned that MySQL Autopilot can improve runtime performance for queries? Well, I think a lot of databases do that, right? I mean, they look at statistics, they gather statistics even when a query runs, and next time you run the same query, maybe you get a better result. MySQL Autopilot is different. We gather statistics from each part of the query, and we apply that to other queries. So in the query on the left, if you're not familiar with that kind of notation, we're joining together 3 tables, A, B, and C. Okay, and the query on the right, we're joining together A and B, but now we're unioning with another table, D. MySQL Autopilot is able to use what it learns in that first query, query 1, A joined with B, joined with C, and apply it to query number 2 and improve the performance of query number 2. Now, this makes a huge difference. MySQL Autopilot improves the performance of TCP/H and TCP/DS by 40%. So just by turning on this query optimization to learn from one query and applying it to another, MySQL Autopilot improves performance by 40%. I mean, that's big. When you're running an application, that has a mixed workload, and by the way, I think pretty much every application has mixed workloads. Some short transaction thing, some interactive screens driving some back end of the database, plus some decision support. Now, maybe doing some reporting, maybe doing some analytics, right? Maybe just doing some batch processing. You get a mix of different sorts of queries that are running. Some very short, some very long. And the problem is that all of those queries, they're competing for the same resources inside the database engine, right? And so now, how do you schedule those things? Well, I think the way most people do it, most databases do it, is it's just a queue, right? First in, first out. And the problem with that is that long-running queries slow down fast-running queries. Fast-running queries where a human being is waiting on the result, right? Long-running query, running report, so it runs a few percent slower. Who cares, right? Human beings sitting there at the screen having their short transaction running slow. Well, they don't like that, and that means maybe your customers ordering from your website are now quite annoyed. Well, MySQL Autopilot includes auto scheduling. It predicts the execution time for queries and uses that to do something smarter than just a FIFO queue. It prioritizes short queries over long queries. It doesn't allow starvation. You don't have to worry about that. Okay, but what it does mean is that the interactive parts of your application, the web pages that you're presenting driven by data from MySQL HeatWave, those users are going to be a lot happier. So here's some data showing what happened when we used MySQL Autopilot auto scheduling with TCP/H. Now, some of the queries are very short, okay, and those queries, their elapsed time shrank by 45%. So the short queries that correspond to interactive screens in an application, they finished 45% faster. That's great. Now, there's no free lunch. If you speed up some queries, some other queries are going to run a little slower. So the long queries, they slowed down by 6%. But if what you're doing is you're trading off, interactive experience of your customers, interactive experience of your internal users versus, reports running a little slower, I think we'd all pick, let's make the users happy. Okay, I'd now like to introduce to you Nipun Agarwal, who's going to give you a demo of MySQL HeatWave.
Thank you, Edward. What I'm going to show you today is how you can use the MySQL Autopilot features, which Edward talked about, and use it with our publicly posted benchmark to verify the results. I'm going to start off with the first feature, which is auto provisioning. So for that, we're going to log in to an instance of the MySQL database, which has 4 terabytes of the TPCH data loaded. The first step is to determine what's the right size of a HeatWave cluster. For most of the services out there, the onus is on the application to determine what's the optimal cluster size. With MySQL Autopilot, users can invoke the MySQL Advisor, and this advisor, the only input that is required is the schema or the table on which you want to run analytics. So we're going to select the TPCS schema, and the system tells you very accurately how much of memory is going to be used and what is the size of the cluster that is required. This is fairly interactive, where you can go and deselect some of the tables if you want to see what change will it make in terms of the recommendation. So when we deselect the line item table, which is the largest table, you see that the size of the cluster reduced from 12 nodes to 4 nodes. But since we are going to be using TPCH as the working example, we're going to go back and select the entire TPCH schema. And the system is recommending that we create a cluster of 12 nodes, and that's what we're going to do. And with this, now we are provisioning a MySQL HeatWave cluster with 12 nodes per the recommendation of auto provisioning. Once the cluster has been provisioned, the next step is to load data from the MySQL database into the HeatWave cluster. So for this, we're going to invoke the AutoLoad Advisor. The AutoLoad Advisor does two things. The first is, based on the data which is going to be loaded into the HeatWave cluster, it determines how much of memory is required on the HeatWave cluster and how much of memory is required on the MySQL node. And if it turns out that the memory requirement is larger than what the system has, it's going to issue a warning before the load starts. The second thing is, for each of the table which is going to be loaded into the HeatWave cluster, it determines what's the optimal degree of parallelism. The optimal degree of parallelism is such that it minimizes the load time, at the same time minimizes the memory requirement. So what you will see over here is that for the line item table, it's picking a degree of parallelism of 32, and for the nations table, it's picking up a different degree of parallelism. Once the data has been loaded into the memory of the HeatWave cluster, this loading is done based on the primary key. So the primary key is the default key on which the data is partitioned in the memory. Based on this partitioning, we run the 22 TPCH queries, and we see that with this default partitioning, it takes about 18 minutes to execute the queries. We're now going to invoke the Auto Data Placement Advisor to see what recommendation it has. When we invoke the Auto Data Placement Advisor, the Data Placement Advisor makes a couple of recommendations. The first one is, it recommends if any of the tables which have been loaded into the memory need to be altered and repartitioned based on some other key. So in this case, it's making a recommendation that the line item table and the part supplier should be partitioned on a different key. The second thing which the advisor does is to predict the amount of savings you're going to get if you partition based on the new key. So the system is telling us that we're going to save 5.5 minutes if you follow the recommendation, and we're going to follow the recommendation and we execute the command to alter the partitioning in memory. Once the data has been repartitioned based on the new key, we are going to run the 22 queries again and see what the performance is. When we rerun the queries based on the recommended partitioning scheme from Autopilot, we see that the query time dropped from 18 minutes to 8.5 minutes. Now that we have the optimal partitioning in memory, the fourth feature I'm going to show for Autopilot is the Auto Query Plan Improvement. So for this, I'm going to connect with two different sessions. In the first session, I'm going to run query 1, which is derived from one of the TPCH queries, and we're going to run on a fresh instance of the database. When we run query 1, it takes about 2.5 minutes to execute query 1, and there is no history on this instance of the database. Now from another session, I'm going to run a different query, slightly different from query 1, which I'm calling query 2. Query 2 has some similarities with query 1. So for instance, it's selecting from the same set of tables. It has some common predicates, but it also has some differences, like it has some different predicates as well. When we execute query 2, the system learns from the execution of this query. For instance, what was the size of the intermediate results? So the system learns from the execution of query 2. And then when we run query 1 in session 2, it is going to come up with a better execution plan. So now when we run query 1, we see that there is a significant improvement in performance in query 1's execution. The execution time dropped from 2.5 minutes down to 30 seconds. And this is because of the autopilot, which is turned on by default. I will now turn it back to Edward.
Thank you, Nipun. Now, I think you can see from Nipun's demo and the slides we saw earlier just how impactful Autopilot can be. He demonstrated on TCP/H, but for real customer applications where we tried this thing, it really has made a huge difference. Now that we can do MySQL Autopilot, the question is, let's turn to scale. Can we manage even more data with MySQL HeatWave than before? And the answer is definitely yes. For one important aspect of scale out is ability to load data. So when you have an analytics engine sitting next to MySQL engine, now in MySQL HeatWave, they're exactly the same database. It's the same data. It's just mirrored in the analytics engine as compared to the OLTP database, right? And so when we move data into the analytics engine, that can take a while. Maybe to fill a large MySQL analytics engine, a large HeatWave analytics engine next to MySQL OLTP, it might take hours, literally hours, just because the volume of data is so huge, right? And the data has to be transformed to an in-memory representation that HeatWave can query very efficiently. Now, one thing that we've added now to MySQL HeatWave is the ability to store that data, the data that we formatted into the HeatWave format, store that into Object Store. Object Store is an OCI service. Now, when we do error recovery for a node, like the node has to be restarted, we don't have to now reload the data from the MySQL OLTP instance. If we have a total crash of the cluster, then every single node has to be reloaded. They all can, in parallel, load from OCI Object Store that data which has already been put in the right format. And just to give you some idea about the difference, right? So in one of our OCI data centers, we've tested basically loading the original load into the HeatWave format took 7 hours. We can now do it in 4 minutes. That's a dramatic improvement in performance. It's quite important when you think about availability. If something bad happens, and it doesn't happen very often, but it could happen, we can recover from that crash very quickly now. Now, we currently only use that technique for error recovery, but we're working to add it to just restarting the instance or upgrading the instance or just reloading the data. Now, MySQL HeatWave has always been secure. When we released the product, MySQL HeatWave, it stored the data encrypted at rest. It was never stored unencrypted. Now, inside the MySQL HeatWave system, though, various nodes and various pieces of the implementation, they talk to each other over the network. So, the nodes and HeatWave analytics engine talk to each other. The OLTP engine talks to the analytics engine over network. That was not encrypted, right? Well, now everything in MySQL HeatWave is encrypted. So as the data moves across the network, it is encrypted. As the data sits in any kind of persistent store, it is encrypted. So your data in MySQL HeatWave is now always encrypted. Red3i, they are a digital marketing company. They migrated a 6 terabyte database from AWS Aurora. They've achieved 1,000 times improvement for some of their complex queries. They had queries that sped up by 1,000 times. Now, these are not artificial benchmark queries. These are not queries that we created for them and they tested. These are real queries in their real application that they depend on in their production application. They moved their 6 terabyte database from Aurora to MySQL HeatWave, and they achieved 1,000 times improvement for some of those critical queries. Overall, they got an 85% performance improvement, right? And also, they spend less money. What they found is that MySQL HeatWave is 60% cheaper than AWS Aurora. MySQL HeatWave can now process more data faster. So before, when we first launched MySQL HeatWave, we could process up to 12 terabytes of data using a total of 24 nodes. Well, now we can process 32 terabytes of data using 64 nodes. And even more, we can actually do this much more efficiently. If you've used any kind of cluster database before, or really any kind of clustered server products, any kind of cluster technology, you know that one very important characteristics of a cluster and a clustering technology is scalability. So what scalability means is that as I add nodes to the cluster, what happens to my overall efficiency? Now, Sometimes, in some kinds of technologies, as you add nodes, you get to a point where the efficiency drops dramatically. So every time I add a node, it's not like I get that full node's worth of performance. In fact, some kinds of technologies, you reach a point where the overall system performance actually begins to drop as you add nodes. Perfect scalability is 1.0. So as I add nodes, I get that an incremental efficiency boost, which is equal to the capacity of that node. So if I double the number of nodes, the performance of the cluster doubles. Now, when we first announced and first released MySQL HeatWave, we had very good scalability. And you can see that on the bottom line, right? So you can see that as you add nodes to the original MySQL HeatWave, I got a little bit better than 80% of that node's capacity, and it was pretty flat. Not perfectly flat, but pretty flat. MySQL HeatWave is now much better. So not only can we scale up to more nodes, all the way up to 64 nodes, but the scalability is now 0.89. So that means that as I add nodes to my cluster, I get to take advantage of 0.89 of the capacity of that node, adding it to the efficiency of my overall system. Now, we did some updates. When we first launched MySQL HeatWave, we did some benchmarks against Redshift, and we talked about those back in December. Well, we've now benchmarked our most recent version of MySQL HeatWave against their most recent version of Redshift Aqua. Well, we're now 13 times better price performance, up from 7 times. So we went from 7 times better price performance to 13 times better price performance. 6.8 times faster at half the cost. Now, you think maybe what Oracle did is we picked the right exact point, between performance and price to give us the maximum possible, 13x better price performance. How about what we do is we make Redshift cost the same as MySQL HeatWave. To do that, we've got to go from 8 Redshift nodes down to 4 Redshift nodes. Well, when we do that, they now are slightly cheaper, very slightly cheaper. Well, now we're 18 times faster. So we get 17 times better price performance. If you spend the same amount of money in Redshift, you get to run 18 times slower. That's not a good deal. And by the way, for these benchmarks and every other benchmark data that you see in this presentation, you can find them yourself on GitHub. You can go to GitHub, you can download our code, you can run the benchmarks yourself. In fact, I encourage you to. Please download these benchmarks and run them yourself and see for yourself. You'll see just how terrific the price performance of MySQL HeatWave is. I'd now like to introduce or talk about Fancom. Fancom migrated from Aurora to MySQL HeatWave without any application change. Remember, that was one of our most important criteria at the beginning of MySQL HeatWave. Be able to move applications without any application change. Their performance improved 10 times over Aurora. 10x. That's huge. Their cost dropped significantly. You get more performance with MySQL HeatWave, and now with the recent innovations, performance is even better. We're now going to compare ourselves to Snowflake. We are much better than Snowflake. 35 times better price performance to Snowflake. I mean, if you thought 13x or 17x price performance advantage over Redshift was big, we are 35 times better than Snowflake in terms of price performance. Now, the cost you see on the right is compared using list price. Their list price, our list price. We have to use list prices because Snowflake doesn't publish, they don't publish a discount schedule. There's no way to know what kind of volume discounting you may or may not get with Snowflake. You can get a discount from them, you can get a discount from us. But I guarantee you, there is no level of discount they're going to be willing to offer you to make up for a 35 times price performance gap. Now, let's look at a collection of databases you're likely to choose from all together on one slide. MySQL HeatWave is by far faster and cheaper than Redshift, than Synapse, than Snowflake, than Google BigQuery. I mean, we've already compared ourselves multiple times to Redshift. You've seen that. Well, when we compare ourselves to Azure, what we find is Azure is a little bit worse than Redshift. Snowflake is a lot worse. Google is even more bad. Even Google BigQuery is terrible. MySQL HeatWave has by far the best price performance of any of these competitors. We're faster and we're cheaper. And by the way, this slide understates our price performance advantage. All the comparisons that I did before, we didn't account for one very important thing, that when you use MySQL HeatWave, you're getting OLTP and query performance together. You're not having to pay for a separate OLTP instance and a separate analytics instance. When we do a price performance comparison to Redshift, somewhere there's an OLTP database that's generating that data that you're loading into Redshift. The same for Synapse, the same for Snowflake, the same for Google BigQuery. So the true price performance advantage of MySQL HeatWave is much better than we've shown. MySQL HeatWave lets you accelerate more workloads. It's not just an OLTP database. It's not just an analytics database. It is a database that runs, frankly, what I consider to be real-world applications. Real-world applications run both transactions and queries. They have transaction processing and decision support in the same database instance. Now, I realize a lot of you might not run that way, but think about your actual application. Think about what you need to do in your application. Do you take data from your OLTP application and move it to some other engine to run queries? Is that because you want to, or is that because you have to? Well, with MySQL HeatWave, you don't have to. Real-world applications have both transaction processing and decision support, analytics, report writing. And real-world applications need to run both transactions and complex queries. So now we went out, we tried to find a benchmark that actually validate the fact that you can do both of those things with MySQL HeatWave. The best one we could find is something called CH Benchmark. Now, CH Benchmark was designed by TU Munich in affiliation with some industry partners. It combines TPCC transactions and TCP/H queries. It measures throughput and latency. When we run the CH Benchmark using 100 gig database, it's sort of like your, kind of your bread and butter database size. Probably a lot of you have a lot of databases that are about 100 gigabytes. That seems to be very common, right? Running 100 gigabyte CH Benchmark with 4 concurrent OLAP sessions, our latency is 18 times lower than Aurora. Right? If you want to think about, hey, what if I just use Aurora instead of using MySQL HeatWave? Because I got to run transactions, I can't use Redshift. Well, if you run CH Benchmark on your database application, comparing Aurora and MySQL HeatWave has 18 times better latency. Throughput, 110 times better throughput. I mean, if 18 times is great for latency, throughput 110 times better for HeatWave. Aurora not looking too good for CH Benchmark. How about the cost? Well, if you want to run with 18 times better latency, 110 times better throughput, you also have to pay 60% less for MySQL HeatWave. Now, maybe you're thinking, hey, I am the one unique application in the world that doesn't actually have any kind of decision support as part of my application. The only thing I ever do is run transactions. I never look at the data. I don't think there's really a lot of applications like that in the real world. Maybe there's really none. Okay, so if all you ever did is just run transactions and you didn't care about the information that's being entered into the database through those transactions, okay, that means just in terms of CH Benchmark, that means just run the TPCC part. Don't run any kind of decision support queries. If we compare Aurora to MySQL HeatWave, the latency is the same. The throughput is the same. The cost, however, is not the same. So even if you're that unicorn application, that for some reason has transactions entering data in the system, but no kind of queries making decisions based on the data, it's much cheaper to use MySQL HeatWave. Now, when we first launched MySQL HeatWave back in December, there were certain queries that we couldn't run in an analytics engine. Just, we hadn't gotten to run all of those elements of SQL yet. Well, we've now closed almost all of those gaps. So we can now run window functions. And by the way, we use a pretty unique approach for window functions. We don't require global sort. We can distribute those window functions across all of those HeatWave nodes. We support rollup, union all, scalar subquery support, on and on. In fact, if you look at TPCDS, we can now run all 93 TPCDS queries that are supported by MySQL. So if you go to any implementation of MySQL, it could be your on-premise MySQL database instance, it could be some other MySQL database service. Oracle MySQL HeatWave can run all 93 DPC-DS queries that those other databases can. When we launched MySQL HeatWave, we delivered a service with just incredible price performance. I mean, we showed you at the time, how it compared to Redshift and others, right? We showed you how it compared to Aurora. Well, now with these key innovations, we've added innovation using MySQL Autopilot, automation driven by machine learning specific to your instance. It gives you a better experience and it gives you much better performance. We've added more scale. You can now scale up MySQL HeatWave to 64 nodes, managing 32 terabytes of data. And the scalability has improved by 20%. So our scalability is 0.89. I mean, that's an amazing thing across all those nodes. The price performance of MySQL HeatWave is now even better than it was before based on these innovations. And I think if you look at MySQL HeatWave and compare it to any other service that you're considering using, MySQL HeatWave is by far the best choice. Thank you.